Okay, here we have stationary waves in a pipe. Okay, to create a stationary wave, you could create one by blowing across the end of a pipe. You could also put things like a speaker on the end of a pipe and so on to make a stationary wave in a pipe. Just think of a pipe instrument, okay? Waves travel down the pipe and reflect off the other end. Okay, so that includes reflecting off an open end. So this here is a tube that is closed at this end and open at this end. Okay, so a wave can get pushed down down the tube here, reflect off the solid end and come back. But then it actually reflects off an open end and goes back in. Similar here, this is a pipe that has two open ends. If you keep sending waves down this way, they can keep getting reflected off this end, then reflected off this end and so on. How do they do that? Well, we'll talk about that in class, but generally it's got something to do with pressure changes. So here we have some particles down a pipe. So remember, if you send sound waves down a pipe, they are longitudinal waves. So because this is towards an open end, you actually get the antinode at the open end here. And down this end you actually get, let's say, no movement. What we'll draw here will be the fundamental, okay, so the fundamental standing wave. So here we have what I'm drawing here is the back and forth motion of a longitudinal wave that is inside this pipe. Okay, so as you go out, the motion of these particles gets bigger and bigger. Hopefully I'm going to draw that bigger and bigger. Oh, this one's going to overlap. Sorry about that. So as we go out, the motion of the particles get bigger and bigger until you get the biggest at the entrance and nothing at the end here. So to draw what the wave actually really looks like, well then we just draw our general superposition picture. Okay. So first up, let's look at some closed pipes. So the fundamental has one antinode at the top here and one node down the bottom there. Okay, so if we draw that in, these should be nice curves. It's quite hard to draw with a mouse, okay, but that's it there. The next one is going to have an antinode at the top, okay, so there should be antinodes at every open end, okay, and there's going to be a node at every closed end, okay, so there's nodes all along there. Now what we're going to do, at each one, what you do is you just add in another node. So I'm going to put a node here. Now, how much of the wave is this one here? It's actually a quarter of a wave, okay, or quarter of a wavelength. So I'm going to draw half a wavelength here, and then the last quarter there, okay. So think about that when you draw these waves. Okay, remember we're drawing it like this because you've got to show the extremes of amplitude. Even though it's a longitudinal wave, we sort of still draw it like a transverse wave. So the next one now is going to have another antinode included. Okay, so it's going back and forth much quicker. Like that. Okay, like that. So in this one here we've got 1, 2, 3 nodes and 1, 2, 3 antinodes. I'll let you draw the last one yourself if you like. So what we have here, we have the length of the pipe is from there to there. So how much of a wavelength it is actually a quarter of a wavelength. Okay, this one here, the length of this pipe is equal to 3/4 of the total wavelength. Sorry about that. So length there is equal to 3/4 of the wavelength. Okay, think about that as this is a quarter, so that's a quarter there, quarter and quarter, so it's 3/4 of a wavelength. This one here, well, wavelength goes to there. So how much of the total pipe is that? Well, let's go look at quarters. There's 1, 2, 3, 4, 5 quarters in there, and 4 of those is the wavelength. Okay, so the length of that is actually longer than that, so it's going to be 5/4 of the wavelength. Now the next one. If you put this in here, there's going to be one more node and so on. So we'll leave that one up to you to work out. Now, let's say we want to look at the frequency. Okay, let's say the frequency of this one is F. Well, the frequency of this one here is going to have a wavelength that's 3 times shorter, so it's going to have a frequency that's 3 times greater. This one here is going to have a wavelength that's 5 times shorter, so it's going to have a frequency that's 5 times greater. Okay, the next type of pipe you can have is an open pipe. So remember with these ones, you have an antinode at each end, and to make this thing work, we must have a node in the middle there. So let's try and draw this. Okay, so there we go. So there's the first one. The next one, we still need to have, remember, an antinode at each end. Okay, now we're just going to include another node. So draw like that. Good. Okay. And maybe just draw the last one. So there's going to be 1, 2, 3 nodes in this one. There we go. Okay, and then so on from there. So let's look at the length in comparison to the wavelength. Now remember, each sort of section that looks like this, with this part from there to there, so from there to there, is actually a quarter of a wavelength. So this here makes up half a wavelength. So the length of this is equal to half a wavelength. So if we look at this one here, the length is equal to, essentially there's half there, quarter and quarter, that makes a wavelength. So this is one wavelength. Let's look at this one. So length is equal to, well there's one wavelength, there's 1.5 wavelengths there. So how does that equate to the wavelength? Well, in here we actually have more than one wavelength, so we have 3/2 wavelengths. Okay. Now, if we actually make this one here over 2, we put another 2 at the top, we can actually see that the wavelength steps up. Sorry, so in terms of how it equates the length, but if you actually want to know the length of the wavelengths, they actually get shorter. Okay, you do the inverse of these. So because of that, if this was F, this one's going to be half the wavelength, so it's going to be twice the frequency. This one is going to be 1/3 of the original wavelength. It's now 3 times the frequency. So the next one will be 4. Now you compare that to this one here. This goes up in odd numbers. Okay, so we call this one odd harmonics. Okay, so it's only got odd harmonics. And here's just a nicer diagram, 3D image. Okay, so here we have the quarter of wavelength. If you just draw the line of one of the sides, you can see it ends up there. If I was going to continue the wave, then it'll go right off the screen there, and that's where the full wavelength is. So this is a quarter. Okay, so the length of that is equal to a quarter of wavelength. Frequency equals velocity divided by 4L. Now that's the velocity of sound in air. Okay, so you can actually work out what frequencies you get if you know the size of your pipe, the length of your pipe.